Okay. So my name is Joel Westerberg. I work at Teenage Engineering, a company that primarily makes synthesizers and wireless audio. We work with design, technology, and audio, and we're based here in Stockholm. Maybe you saw Jesper Kautoft on the wall here. You have like people from Sweden on the wall.
Yes, yes, we have people from Sweden on the wall.
Yeah, I noticed that when I came in.
Sounds like reading the Bible and a bad part of it.
But it's also the big picture of the OP1 synthesizer. And Jesper once said that he had a vision to build, that we should build everything that you need on your desk when you work. So far we have built our own synthesizers, speakers, we have our own little screwdrivers for bits, complete with our name on it. Very nice to have. Wireless knobs, desk lamps, even our desks, and we also have our custom CADed computer cabinets. We also have our own line of work clothes in collaboration with Cheap Monday. So this is the cap is from that. So we have this long coats that we use when we work on technical stuff. So it's super nice to have in the lab. So I work at Teenage because I love good design, and as a programmer because I love to code. So I do all sorts of programming in my job, and the thing that I've been working on mostly for the last years is the OD11 as part of the OD11 team. And two of the team is here today: David Mellerstedt, head of software engineering and expert audio engineer, and Jakob Siverskog, OD11 lead and Linux kernel beard extraordinaire. So talk to David about audio and Jacob about Linux. And if you're interested, did I mention that we're looking to hire more developers? So talk to any of us if you're interested in that. So let's step back a little bit and look at the term IoT. So IoT are things that are on the internet. So what does that mean for everything, for you guys as developers, and for you guys as users, or for your customers? I think it surely means that there's a lot of UX work that has to be done in the future. Maybe you've tried some IoT stuff already. Somebody? Yeah? So what have you tried? Okay. Okay, yeah. Seems to be quite common. So, anybody else? Yeah? Flick? Okay, like a little wireless button, yeah? So, have you tried the light bulbs, maybe? Yeah, it's a little bit hard to get them really working all the time. And I think that the reason the IoT light bulbs fail, and a lot of IoT things fail, is because they depend on radio communication. And radio communication is kind of hard. It's amazing that normal home Wi-Fi works as good as it does. I mean, here when we set up all the tech, the wireless stuff, like this computer getting connected, a little bit tricky. The ether is jam-packed with signals, and many routers are like underpowered and that, like that. So we all have lots of things that are not connected to the internet right now, but the future versions of them probably will be. So the key thing here is that it's pretty easy to use. It's pretty easy to interact with the things that you already have, like you open your fridge and you pick out some cold milk, or you press the light switch and the light turns on. It doesn't bounce in North America somewhere before the light turns on. And you open a door with a key and the door opens. It's super simple. And we need to make the new things that we build as easy to use as the things we are replacing. So then, case in point, the OD11. So did you see this speaker here when you got in? Yeah, it's the OD11. It was designed by legendary Swedish audio designer Stig Karlsson, audio engineer Stig Karlsson. It's a 10-liter box with ortho-acoustic sound. So what does that mean? It means that it's designed to sound well in a home. Ortho-acoustic means right, it's acoustically correct. So when we play here, the sound reflects on the ceiling and all of you and the walls. So if you design a speaker to sound good in like an acoustically perfect room, it will sound quite different when you use it at home. So the original OD11 was released 1974. And if I'm not mistaken, it's the same year you were born, Robert. Yeah. It's the same year I was born as well. And David. Good year. Good year. So the OD11 was a hit here in Sweden and sold more than 100,000 units during the 4 years it was on sale. So the OD11 has one cone tweeter here and then one mid-woofer. And that was the name hints at. 1 + 1 = 11. So we can look at a little bit of the other speakers. This one is the OD11, is the smallest one. So this is Stig Karlsson's smallest speaker, and it was called Karlsson Cube. But he did lots of other models, for example, OA12, OA standing for ortho-acoustic, that has one bass and 2 cone tweeters. It's the one to the left, yeah, it's quite common. So, and the high-end one was the OA 2212 that has 2 6.5-inch bass elements, 2 6.5-inch mid-range elements, and no less than 12 cone tweeters for the perfect sound. So you can visit karlssonplanet.com to learn more about all those speakers if you're interested. And so that was the OD11 then. So what has changed? It looks the same, has the same dimensions, but there are some things that have changed. It has a built-in 100-watt Class D amplifier, a computer, of course, and Wi-Fi and Bluetooth LE. Bluetooth LE is Bluetooth Low Energy, also known as Bluetooth 4. It was introduced 40 years after the first one in 2014. So the new version was recreated from the original drawings and was made in collaboration with SSC, Stiftelsen Stig Karlsson. So we can look. There was some interesting stuff that, like the grill here. It was marked in the drawings as vad hette den? Det var så här. What's the name of the grill? It was a järnduk number 10. Yeah, woven mesh number 10. Iron woven mesh number 10. Järnduk number 10. So we have recreated that faithfully. So let's pop the hood and look inside. So it has a U-shaped bus. What's new in it? It has a U-shaped bus reflect duct. It used to be like just a tube, but this one is for extra powerful bass. So it has the amplifier on one side and the auto engine computer on the other side. And putting the amplifier on the side of the duct makes it keep cool with the passing airflow. And all our products are made to look good to the core. So if you open up any of our products, you'll void the warranty, of course, but it will be a pleasing experience because if you like to look at hardware. So even the screws are selected for the right optical properties as well as functionality. So everything looks super nice inside the all the parts. For all our products, if you open the synth, get a nice message that says you have voided warranty, and then see if you see this, you have voided the warranty. So the auto engine, this is the computer inside. So ARM has an ARM chip and software that talks to our cloud and streams music from the internet. You can stream music from Spotify, AirPlay. And it also runs our custom version of Linux, a custom version of OpenWRT, which is a distribution you can customize. So what can you do with it? You can play from AirPlay, of course. So you start a session from your computer, and then you stream to one speaker, and then it restreams to the other speaker. And you can play from Apple TV. You can have it as the audio out, and it plays the sound in sync with the TV. Spotify Connect, you can play in Spotify. You can use line-in, optical in to play. So the OD11s actually have two Wi-Fi networks. The master speaker joins your network, and the slave speaker joins the master's work network, which is dedicated to low latency audio. So we have UI software that works both on the web and in applications on Android, on iPhone. But I was thinking that I should have the demo now, but for technical reasons, from Robert's side, we're going to do it afterwards. So we can get a good recording of this. So, key features of IoT and how they sometimes stand in opposition with each other. I'm going to talk a little bit about the choices you have to make when you make an IoT product. And I'm going to present the four key features, or the four key dichotomies that you can that you have to make a choice in between. So the first thing is that you want the setup to be super easy, but you also want it to be secure. So this is a key problem with all the IoT things, is that you need to get them on the internet. And we think that WAC is the best solution. It's Apple's wireless accessory configuration that you can use to add Wi-Fi devices to a home network. So how you use it is basically just to select the item from the Wi-Fi menu, and then it automatically joins your network. It's super nice, but it's part of Apple's Made for iPhone program, so you have to have Apple's special crypto chip and be certified to use that. But I'm really hoping that there's going to be a good solution from Google for this thing as well. So maybe you have some intel for me.
For technical reasons.
But if you don't have an Apple product, then in lack of automatic features, what's left is to provide an open captive network that you can start, where you can enter your Wi-Fi credentials. So we have incorporated this into autoplay.com, which is like this site. So you just go there, you put your OD11 in config mode, and then it discovers the OD11 when you switch networks, and then you enter your password, and when it has successfully joined the other network, you can jump back to the other network. Works quite nice. We do encrypt the password, that is when you enter it, as it's transmitted over there. using public key cryptography and a one-time key. Try to make it as secure as possible. So there are some rather different approaches to this. For example, if you have bought something from Amazon, you know that if you have another device already and you get like a Kindle back, it's already configured for a wireless network because they have stored your network credentials at their servers. So it's kind of snazzy in one way, but a little bit scary in some other ways. But also, when you have set up your device, it should stay on the network. So it's like, it seems to be a lot of problems with IoT devices that just lose their tokens, like light bulbs that lose their OAuth tokens or whatever, and they can't refresh them. So key thing is to have them remember their configuration, regardless if they were updated or whatnot. So then when you have your device on your network, you want to interact with it, and that should be fast but also accurate. For applications, you can use Bonjour, which is a discovery protocol from Apple. It's not all that robust, so but it works sort of okay, but not very robust. But it's not a choice if you're doing JavaScript apps because they're sandboxed. So our discovery method is that all speakers report their current local IP to the cloud. And then we do a lookup when you go to interplay.com and match your IP to the IPs of your speakers. And then the web page can call them up on a local WebSocket connection. It's simple and very robust. And you can also remember, we also remember the IP of the last speaker, of course. So it's super fast. And then we need the device to be updated, but we need to be able to use the device at all times. So the most critical feature of all is like software updates. So the Spotify ecosystem, Apple ecosystem, Google ecosystem, they all change and evolve. OpenSSL gets Heartbleed, good thing to patch. So you want to be able to update your devices. And one of the things we have chosen not to do is to have automatic updates. It's because it's a speaker and it's super annoying if the music just stops when you're listening to it, or maybe you're using them in a commercial setting or doing a presentation or something and it just updates. It's like when you launch your game console and it starts big, you enter gray bar land looking at the progress bar before you can start your game. That's a compromise, that's a decision they make. The game console makers did. They wanted to be always to be updated, but we did another solution to that. Want to keep it in the hands of the user. So it should be easy to use and intuitive to use, but with enough depth. So the UX challenge of input devices that are physical objects, it's a super big challenge, because it's the building, let's say, IoT things often look like what they are replacing, but they have more depth in the usage pattern they support. So this is the auto remote, same size as a snusdosa, but it has quite a lot of features. It's the same nice feeling of holding it in your hands, holding snusdosa. But this one packs a lot more punch. So actually building something like an IoT sensor network is quite easy, but I'm sure you all can do it in like a day or half a day, building something that talks to the internet and reports back to a server. It's quite easy. But building a more involved product like a speaker that has a complex interaction pattern entails a lot of work. So user interfaces are always the most complicated code in any software project, because the number of the number of features you have that you want to support makes, and the number of there's actually users involved. So when you use something, they can do lots of things. When you have just code that talks to code, it's a lot easier. And I think that you can look on, let's see. We consider it's a relation much like algorithmic complexity and UI complexity regarding the number of usage patterns and features you have in a product. So when you use a program or a thing, you want to make something happen in the world. Like you want to send a message to another human being. You have an idea of what you want done, but the road is a little bit unclear. So why is it today, in 2016, we just can't tell a computer directly what we want to have done? Like if I want to rename some files on my computer, I want them all camel case, remove the blank spaces, replace with underscore, add some date stamp at the end, convert to PDF. It's quite easy. You can do it with the Unix command line, but you have to spend a couple of minutes with awks, xargs, sed, and whatnot. Solution in iOS world or Android world? Do you have files? Yeah, good stuff.
We get more files.
Yeah, good stuff. So I think removing the files is a bad idea, because we humans like to organize stuff in a spatial manner. Do you remember the old spatial finder from the old Macs? It was so good. Super nice. You could like remember what things were where. Of course, you only had like 2,000 files on your hard drive, and now you have 1,000 times more, or maybe even more. But that model of like spatially organizing stuff harkens back to medieval times, and this concept of the memory palace. You have a memory palace. It's a mnemo technique from the monks in the medieval era, where you had like you visualized a room in the cathedral or wherever, and you would have something that you wanted to remember, and you would go to like a desk or something or put the thing you want to remember in a special place. And then when you wanted to remember something, you would like enter this mental space, and you would say, okay, I really need to remember this. And if you could remember where it was, you could also remember what it was that you wanted to remember. So as Internet of Things makes physical objects become input devices, this is an inversion of what traditionally has been the modus operandi of building applications for computers. This skeuomorphic-ism, making pixels look like natural tools. So preferably it shouldn't look at all. It should just do what you want it to do, and fast. It's like most of the icons today are already antiquated and going out. Like save and pressing the save diskette doesn't mean anything to kids. What's this? Oh, it's a save symbol. So I think that the future is in using words for interface, and then for intelligent deterministic behavior, that you can depend on things working a way that you can understand. Like the IoT, like locks that unlock when you come home. What does that even mean? So if your Wi-Fi turns off at home, does the does the lock think you have gone away because you're not at your Wi-Fi? Or is the door always unlocked when you're at home? Or is it randomly unlocked when I'm at home? It's really hard to tell. So IoT things should work as you're used to, but smarter. So one of the things we've been thinking of adding to the OD11 as an accessory is a vinyl record player. So you can play vinyl records, good stuff. But we can also make like a special vinyl record that has a recorded time code. And you can connect that to a Spotify playlist. And you can use your old way of selecting song and playing just by interacting with that disc. Generally, there is an illusion of productivity with complex interfaces. So if it looks complicated, it must do a lot of stuff. But like Excel on an iPad, it's a super complex interface on a device that you use for consumption. There's no need for that. So auxiliary devices. So the OD11 is a multiple master setup. That means that each speaker can take the role of a hub, the master restreamer. So if you pull the plug on one of them, the other one just takes over. And when the other comes back online again, they will negotiate who will be master and who will be slave again. But in the Internet of Things, not all items are directly connected to the Internet. Some auxiliary devices connect to another item and then on, maybe to the cloud. For the OD11, we have a remote. Looks like this. You can press it and start playing. You can skip and pause. It's a Bluetooth LE volume knob where you can play, skip, go to previous song. It's an IoT thing, even though it doesn't really connect directly to the internet, but it still needs software updates, and it's inside there's a energy efficient Nordic semiconductor processor and battery lasts for 2 years. So if we look back at what's included in building an IoT appliance like this. At the base, the device is a white cube with 2 speakers in it, integrated amplifier, radio, and a computer. So if configured so, it can work in cabin mode. It's a Swedish product after all. So you can bring it to your summer house and play, stream or play on a local network. You can connect it to broadband and then you can play, stream from the internet. In cabin mode, you can use the built-in web server and the locally hosted version of Autoplay. But beyond the local network, the device needs a connection to the internet for discovery, updates, and more. Supports involved in this is the hardware, the device software, the cloud software, the infrastructure, the client applications, and integrations with streaming services. And we have a polyglot platform with parts written in C, C++, Python, Ruby, Golang. And from the app side, we have JavaScript, Objective-C, Java, and possibly Swift in the future. All these languages have their own strengths and weaknesses. So we try to apply the right language to the right job. And well, C, fast and uncomplicated, perfect for low-level stuff. C++ is what you pick when you have to do real programming. It's fully featured, ready for any task, and yes, it's fast. Python is straightforward and malleable. Ruby is elegant and concise, a little bit slow. Golang, the newcomer, feels like a mixture of Lego and Python. The type checking makes it easy to snap pieces together, and the duck typing makes it feel modern. I feel like the main thing with Golang is that when it compiles, it just runs as expected. It's if it compiles, it just works. Super great, I think. And on the client side, we have JavaScript. We all love JavaScript these days. I think the main reason is that it has no threads, so it makes async programming work as expected. So we do some stuff in TypeScript as well at Teenage. Do you know what TypeScript is? It's a language from Microsoft that compiles down to JavaScript. Transpiled, maybe the correct word. So we built this desktop design tool just for our website. It's like Illustrator, but in the browser. So you can design your pages, select what you want to publish, and it's all like a desktop layout paradigm. You can nail exactly how you want it to look. And then we publish that to Amazon S3 and the CloudFront. So the site can handle any load. So it's a JavaScript site, but it's statically published. It's one of the things we've been having fun with. So Objective-C, roots in Smalltalk, superset of C, super delight to work with, but it's now scheduled to become replaced by Apple's new Swift language. I don't know really how I feel about that, but I like the Smalltalk stuff. Java is like C++. If you know it and program it, you don't understand why everybody else complains about it. I think that the main complaint from my side doesn't really. It lives in its own world. It doesn't really have any connection to the operating system. You have to optimize the JVM instead of optimizing the operating system. It doesn't even get the command line options right, and all sockets and stuff. It doesn't feel right. So should you build your own or use existing infrastructure? In the later part of the presentation after the break, we look a little bit at different stacks, but platform-wise, we built on Amazon and Heroku, and we decided to roll our own. And a key proponent for this is, for writing your own stack, is managing complexity. By building your own, you can be sure on functionality and keep the code base small to the point and cherry pick what libraries you want to use, preferably open source. So it's possible to dive down in the stack in case of problems. Since we build hardware, we do occasionally debug with oscilloscopes and logic analyzers in the early development phase, and it's nice to have the possibility to go down to the root of any problem and understand the exact nature of any problem before fixing it. I think it's a key thing. Don't just work around something without knowing what you're working around. Nail it, understand it, and make damn sure you solve the actual problem. For example, we do a lot of signing and verifying messages with crypto, and there was a server-side process that was leaking leaking memory somehow. It looked like a memory leak. And we looked if there was leaking Ruby objects or something, but it turned out clean. Then we did a narrowing down exactly where in our code we were leaking, found the likely culprit, isolated that bad boy to a simple script with no dependencies and verified. And then we just downloaded the Ruby source and checked that part of the Ruby code and compared it to the OpenSSL documentation. And sure enough, there was a missing call to clean up for an OpenSSL thing. So I filed a bug. Ruby team fixed it 1 day later, super nice. And then it was out in Heroku production just some days after that. I think that Ruby as a language and as a community has the best tools. It's like a community obsessed with making super nice tools. And I think that's super critical to make good tools. And that's what I like about open source. It's not out of reach to look into exactly what the program is actually doing. I do that all the time, even when there's not a bug. It might be, that is open source, not all that well documented. And one of the reasons we built our own cloud is the realization that an IoT device starts its life in the factory. As units are produced in the factory, they talk to our backend to report test and measurements. And it's not that easy to integrate something we produce in China, not that easy to integrate something from China to, if we would select a vendor, an official vendor, that talk directly to them. So you have to have special stuff to get through to be able to talk to your server, not So we start and run statistics on all kinds of measurements from the factory LAN and make sure that the allowed ranges are narrow enough to assure quality. We also manage the life cycle of tests so they can invalidate the product if it fails a later test. We also gather and aggregate audio test data so that we can be sure all speakers sounds equally great. And it's super nice to have the factory stuff if you want to track down any problem or return. You can just look at, see, okay, was there something special when this item was produced? So how does these things work together? The factory talks to the cloud to provision devices and more. OD11 talks to AutoCloud, and the user who's listening is interacting with the OD11 and AutoCloud. So the OD11 reports regularly its IP address. And we made here's a design choice that we made. It's that many of the IoT devices out there have a reverse tunnel to the cloud. We didn't feel comfortable doing that and being responsible for that tunnel. So our device reports back to the cloud, gets information, maybe potential software updates, and then lets the user act upon that. I'm sure most tunnels are done with good intentions, but just look at your iPhone, your Mac, or PC. What are those IPv6 tunnels doing there? It's we've done if config and see. You can see like tunnel promiscuous mode. What's that? So we have different kinds of data. We have fast and slow data. Should I speed up or what?
It depends on how much you want to say.
Okay, I have so much to say.
Slow data.
Sorry? Slow data. Okay. Yeah. So we get all kinds of runtime metrics and things that we aggregate to keep the platform running smoothly. Most of these things are handled batch-wise. If the user signs up for a TID, the data can be used for troubleshooting. And then we have other data that's critical, it's up-to-date and accurate. Then there's data that we trickle out, like software updates. The fast and per device data is ideal for a NoSQL-like setup. Factory line data is ideal for a beefy SQL database with proper normal form. Statistical data is ideal for flat file and MapReduce type operations. For example, we aggregate Texas Instruments Wi-Fi recoveries per time unit and firmware release so that we can get feedback. So we can feed that back to TI's team in Israel and get the improvements we need. So building your own Linux distribution. Building something that uses Wi-Fi sort of requires Linux. It has really good Wi-Fi capabilities. And having our own Linux distributions means we can streamline the install size and keep pace with the Linux kernel and make necessary adjustments to the kernel. And we have submitted a couple of patches to the kernel already. So in your home environment, the OD11 can look as chill as this. And we have been building synthesizers that are not using wireless connectivity, but now we are, and we have a new synth in the pipe, OPZ, which is a video synth and more, and we are continually improving the audio level. That's the end of part 1.
Do you want to? Oh,
okay. All these platforms have their own solutions for discovery, connectivity, and security. And some provide an operating system, some provide just a protocol, and some provide hardware, or all of the above. And generally, it feels like the IoT space is not very mature. Lots of competing protocols and solutions, and nothing is set in stone yet. Do you hear what I say? Yeah. So many of the projects that we're going to look at are still in beta. Many are standards groups trying to collaborate to build the next big thing, and we all know how well design by committee works from the web world, right? And there's also lots of security issues with the platforms. Generally, low power devices and cryptography are not so good friends. A lot of the existing products out there have very poor security. But these platforms try to take on these challenges. So let's look at what they are. So Google has Brillo and Weave. It's a fairly newly released. And it's embedded OS based on Android. Works on ARM, x86, MIPS. You can develop on the Intel Edison, which is nice. Qualcomm Dragon Board platforms. And Weave, so that was the Brillo, and Weave is Google's scalable core platform services for IoT. So features like over-the-air updates, runtime metrics, crash reporting, and a developer console. And not surprisingly, all the Weave, the things that are using Brillo and Weave can talk to each other, as well to the cloud and to your apps. So there's developer kit for Android and iOS. And it's a complete solution with the OS, protocol, backend services. And from what I gather, it's a bit app-centric, but maybe that will change, as opposed to OS-centric. And the details are a little bit muddy, as it's currently in beta and under very strict NDA. So if you're interested, sign up. So I looked a little bit at the stuff, but I'm not allowed to talk so much about it.
So. Yeah, that's enough.
Yeah.
It's in a really early access program, so there are a few invites and people, well, trying it out, basically.
What happened? Where is my... Oh yeah, is it... oh. Something messed up on my. I got a pop-up. For technical reasons, I got a pop-up, so had to break it down. And Samsung has something called Arctic, which is a hardware platform with a range of ARM chips from 1 core to octa-core, and it has a range of capabilities like Wi-Fi, Bluetooth Low Energy, Zigbee, which is a radio protocol with longer range than Bluetooth, which is based on the IEEE 802.15.4 spec. And it also has something called Fred, which is also based on the IEEE 802.15.4 spec. But the difference between those is that Fred has an IPv6 layer on top of that, which is called 6-low WPAN, which is IPv6 over low-powered wireless area networks. And so it basically has IPv6 addressing, so it can route out to the internet if needed. And the underlying platform, the IEEE thing, supports various network topologies. So you can have like a mesh network or like well, different kinds of mesh networks, or like a star network and things like that. And you can develop in C, C++, Java, or Groovy, JavaScript, Python. And it's a hardware platform, so it supports some common communication standards. But I don't know about you guys, but developing in Groovy or JavaScript on an embedded device, I don't know. It's supposed to be eco-friendly and like use not a lot of power. You know, like these light bulbs in standby mode, they draw 7 watts. It's well, not that eco-friendly. So Apple has HomeKit, which is like a service protocol thing that's supported by the MFI crypto chip thing. And it uses Bonjour, and it also enables remote access via HomeKit through an iOS device. I don't know exactly if it works if you just happen to have an iOS device at home, but it can work through other routers as well. But it's built around something called HAP, HomeKit Accessory Protocol. And it has like a Bluetooth transport and an IP transport. So their thing is that they have services like a garage door opener, light, lock, thermostat, and that can have characteristics like power state, lock state, target state, brightness, model number, things like that. You can have custom services and characteristics. And then added to the mix, this is something called accessories. And a thing can be several accessories as one and act as a hub, can present maybe some things that are using another kind of network underneath. And you can have, so the interesting thing about the HAP thing, it has network level security, which is kind of cool because the advertising on Bonjour, you can of course see that, but it's not, you can't identify which type of device because the advertisement data is scrambled already on the network layer. And it doesn't use Bluetooth pairing. Bluetooth pairing can have its problems from a security standpoint, and it's operating system level, so you can talk to Siri, if anybody uses that, to tell it to open a door or a garage door. It has quite a long stack of the networks, which is HomeKit on top and then HAP under that. And then the IP stack, basically a RESTful thing with the TCP, HTTP, and the Bluetooth stack. It's a bit different. ARM has something called Mbed, which is an open source OS for IoT things, client library in their own TLS solution. And they also have a server solution that you can buy or rent as a service called the Embed Device Connector Service and Embed Device Server. It's in beta. The companies behind this include Analog Devices, Atmel, Nordic Semiconductor, and TI, Texas Instruments. So they want to do something called that's standard-based and scale it, of course. And then there's this all join, which is something as interesting as a collaboration between the Linux Foundation and Microsoft and some other backers like Qualcomm, Sharp, and Sony. And it runs on various platforms. It has peer-to-peer encryption, and it has authentication via your usual suspects like pre-shared key and elliptic curve signature. And supposedly this one is ready for use. And it has bindings for C, C++, Objective-C, and Java. But that's it. Those were the ones I looked at, actually. So.
I thought you had the technical issue again.
No technical issue.